The big shift this week is that image generation is getting much less dependent on brute force sampling, teacher models, and hand-tuned compromise objectives. One line of work shows you can distill multiple capabilities into a flow model without collapsing quality. Another shows perceptual supervision can cut sampling from dozens of steps down to just a handful. And the sharpest result pushes all the way to one-step generation by matching distributions in frozen feature space. In plain English, AI image models are getting faster without simply getting worse. Keep watching, because the interesting part isn't just speed, it's how these methods change what training a generator even means. Let's explore the first paper, Dance OPD on Policy Generative Field Distillation. Dance OPD is a ByteDance seed and NUS-led on-policy generative field distillation method for flow-matching image generators that treats each capability source as a velocity field and composes text-to-image generation, local editing, global editing, realism absorption, and classifier-free guidance without collapsing them into a compromise model. The core idea is to hard route each sample to exactly one teacher field, query that field on a stop gradient state from the student's own 1/6-step Euler ODE rollout, and supervise with a single low-noise semantic side query using plain velocity MSE. On Z-image, this design outperforms the best reproduced OPD baseline on G-EditBench EN by 8.1% in T2I plus edit composition, and by 16.1% in local plus global edit composition, while preserving or slightly improving Genevol over the T2I source. For realism field absorption on ST3, 5M, Dance OPD improves the realism reward by 9.9% over off-policy distillation and closes 85.3% of the student-to-teacher reward gap, with T2I remaining within 0.1% of off-policy distillation. For CFG absorption, the best measured composition improves over train-only absorption by 7.6% and over eval-only CFG by 1.4%, but excessive absorbed plus external guidance causes a 31.2% drop. Ablations show that hard routing beats soft all-teacher mixing by 15.2%. Low-noise queries beat median, and high-noise queries by 23.7% and 19.5%. Then same rollout querying drops performance by 22.8%, and plain velocity MSE is the most stable objective. Let's explore the second paper, Perceptual Flow Matching for Few-Step Generative Modeling. Perceptual Flow Matching. From Joy Future Academy, Fudan University, Tsinghua University, and USTC, reframes few-step flow matching generation by moving supervision out of VAE latent space and into pre-trained perceptual feature spaces such as VGG, Dynoff2, SIGLIP, ConvNext, and Intern Video 2. Instead of regressing velocity with Euclidean loss, the model decodes the predicted clean sample and optimizes a perceptual distance, which, the paper argues, shifts learning from mean seeking toward mode seeking and makes course integration far less prone to blur. This simple change requires no teacher model, auxiliary score network, or distillation pipeline, yet reduces sampling from 3550 steps to 48 steps while preserving quality. On SD3, medium for text-to-image generation, PFM reaches state-of-the-art few-step performance on COCO 2014 val with 8 steps, obtaining 33.93 FID, 31,7 clip, and 11,4 HPS-3. On Magic Brush image editing with Qwen Image Edit, it matches or surpasses the 4.0-step baseline using only 8 steps and no inference time classifier-free guidance, including 0.9402 clip I and 0.9187 Dino. On WAN 2, 1-to-1. 3B video generation with intern video, 2 supervision, it improves VBench and slightly exceeds the 3-5-step baseline on the overall score, while remaining strong at 8 steps. Ablations show that pre-trained perceptual backbones matter, Randvit fails, and stronger off-manifold penalties correlate with better few-step results. Let's explore the third paper, Representation Distribution Matching for One-Step Visual Generation. Representation Distribution Matching, or RDM, reframes one-step visual generation as direct distribution matching in frozen pre-trained feature spaces, and the paper's key result is that the classical MMD becomes highly effective once it is estimated correctly. The generated side should use large, fresh batches above 2048, while the data side should be frozen once with a 4096 landmark Nystrom reference over the full 128M Image-ImageNet training set. The authors show that matching a single encoder is gameable, so improved RDM balances a diverse battery of 14 encoders with constrained proportional Lagrangian weighting and evaluates with SWR14, an independent slice Wasserstein metric, over the same panel. On ImageNet 256, IRDM reaches a new one-step state-of-the-art at SYR 14.1.3, improving over the prior best 2.05, and PickScore prefers it over the previous best one-step generator on 71.2% of matched samples. The same recipe post-trains Black Forest Labs Flux 2 Klein, a 4B four-step text-to-image model, into a one-step generator that in 90 H200 GPU hours surpasses the original on GeniVal 0.826 versus 0.794, and on PickScore 22.76 versus 22.58, with the joint image text objective clearly outperforming an image marginal ablation. That's a wrap on today's AI paper highlights. Thanks for watching.